Right, I'm live now. Okay. Well, this is working or not. I'm just trying to get my camera lined up. Right, I've been printing parts for this mini lathe that I want to build. I'm going to go see engineering as well because I need a base for it. I can't build anything until I've got the base to build it on, so but all the parts are in here. Well, most of the parts. I'm still printing a few at the moment actually, but right. The most interesting part really would be the chuck, because that's the part that's actually functional, because I've got all these other parts to go on the lathe, but until I've got the metal parts, until I've actually got the metal parts, I can't really put it all together, see, because I need the screws and the nuts and everything else. But here's the chuck. The chuck. Right? And it actually works. I'll have to print a pin for this. I haven't got the right pins in here, so these little green things tend to fall out. When I turn this, you can see it turns on the other side. So the chuck works. I'm using a brush at the moment. See, it's working. It's out. Oops. And in. Obviously it's not going to be like a professional lathe, but it's not going to be very accurate, I suppose, but there's hope that it will be what I want it to be once I get it all built, and I could use a Dremel motor, or I could just build, I'm thinking about using a stepper motor to drive the truck actually. Well, that's the point, because it's got a screw, a worm gear in the back. Now, you can hold objects pretty well. Let's put this pen in here. I'll just turn it on my hand. I don't want to break it, you see. I'm going to turn this with the... I can't get this pen out. But it'll turn a bit, unless I tighten this up. Let's see. Well, it slips a little bit, but remember, I'm only going to be working with plastics initially anyway. But it grips really well. But I suppose if I was to put some rubber things on the chuck pieces for holding plastics, it would grip even better than what it does without that, but it does grip really well. Yeah, sorry about that. I don't want to break it, obviously. Undo it and it comes out. it's the main purpose of the lathe is really for cleaning up 3D prints, really. Well, I mean, at some point, I suppose there's nothing to stop me. If I build the main part of the lathe, there's nothing to stop me actually getting a metal chuck. But it's really to get started. It's to have a building, the basic building blocks of a lathe, and then I can obviously, the real metal should probably cost a lot more money, but it will give me the chance to have something useful. I'll see if I can well, I've got some pictures somewhere actually. Rather than taking it apart, this is basically what's inside the chuck. Right. There's a worm gear, that's this thing here. It's like a spiral, and that's what clamps the workpiece. And obviously the veins that run around, if you put too much pressure on them, the veins will break. But because these teeth on the jaw, these little teeth here on the jaw, are actually spread, the gripping load of the chuck pieces are actually spread over a wide surface area on these spirals, so they're not just on one leg of the spiral, they're actually over several legs, so the gripping energy is spread over a wider area. So, but that's basically what's inside the chuck. It saves me taking it apart. And these are the things I tighten up with the key. So I mean, it's online. I could probably give you the link if I can find it. But basically, these are all the parts so far in my bucket, my box, and so it's an interesting project. It'll be worth doing. It's let's face it, now a mini drill cutting table, that doesn't have all that much strength either, really. So I mean, it's going to be useful for doing projects, and the more I use this, the more I turn this, the easier it gets to turn. Actually, it's easy enough a bit, because it was really stiff when I first started. On it, I can turn it on my hand now. Yeah, it's coming along. There's more work to do. These screws are the right size I put on there. There's the back plate to go on here as well, which is this thing. This back plate goes on here, and then you put the spindle goes in the back of there. You know, whatever. So I haven't put that on yet. Well, yeah, it's going to be a useful little tool to clean things up. Obviously, I'll have to make sure that I've got the jaw pieces centred and that my workpiece is dead centred and everything else, but I can make some adjustments to these jaw pieces, because the 3D print models, there's actually several sets of these, and I mean there's a 3 set, and they're all slightly different because the teeth at the back are slightly offset. So I mean, there's nothing to stop me from altering the nib, the tips, to extend them or shorten them, to calibrate the chuck so that it's properly centred. I mean, if we used to do that in SketchUp, you know. So yeah, and the key fits perfectly. Fits in all the holes. I didn't have to file it at all. It just fits in. It's that snug fit, doesn't fall out. Look. Fits in perfect on all 3 of them. Oh, it's a bit loose on that one. Yeah, but the rest of them it's snug. Fits really nice. So yeah, I've got a few more pieces on the printer bed at the moment, which I'm still doing. Once I've got all the plastic parts done, then I'm going to go up to see the engineering firm and see about getting some metal parts. I need a base really. I mean, the long threaded stuff I can get off eBay, but I don't really ordering a heavy metal or aluminium base off eBay. It would cost me a fortune probably in postage and packing. But I'll just turn the camera around, and that's what's being printed at the moment. Some more bits for the lathe. I'll see if I can get this camera a bit lower. It's a bit saggy. I've actually put a new hot end on, by the way. The hot end that was on the printer actually started to, it wouldn't get hot enough. The set temperature was 260, but it was hovering around 256, 257, and it turns out there was that bad connection I had with it before it came back, and I think the hot end was just failing on me, so I got a new one, which is on there now. And I've put some tape around some thermal tape around the bottom, and a piece of wire to hold the thermal tape on, so I don't burn myself accidentally. It gives some insulation. I've also put the nib, the actual hot end tip, near the front, so you can see it more easily. The old one is, hang on. Right. Here's the old one. I took it off. The element's just it's not working properly, so I got a new one. It only cost a £5 away. So that's the old one. I'll see if I can repair it though, and I'll have a spare. I mean, it's probably just the element. I mean, the actual metal block itself is fine, but so yeah, well, I'll have to take this tape off and we'll have a look at it actually. So if I lift the camera up, camera's in the light. The connection inside on the I'll just undo this and we'll have a bit of a pokey on it and have a look inside. I was meaning to take this apart, you know, but I just haven't got around to it. Might as well do it for the video. I'll wrap this wire around there just to keep that tape from unraveling me. Oops. But why is my hand in the way? Oh, there we go. Right, I'll just take this tape off. Oh, the thermistor's come out. That's the thermistor. The problem I was having with it was with the crimping. It's been getting really hot, you can see. Oh, I've got some Captain tape on here I need to get off as well. Where's my knife? I'll never find the end. It smells a bit burnt. actually, I might get this tape off a bit more. Yeah, it's been giving me a lot of trouble as this for the last few weeks. I had to, at one point it stopped working, I just squeezed the whole thing here with pliers, and it came back on again. Because I know it's the crimping that's the problem. Probably be better if I could. I'm just going to cut this all off actually. I don't want to cut my fingers. Oops, I'll just knock the camera. Looks a bit frazzled inside here. Right. 3 minutes, okay. Right, well the problem is in here. I can probably repair it, but these little brass parts here, what I'm going to have to do is completely strip the wires back here and redo them, and I'll probably still be able to use this actually if I repair it. I'm just going to strip. Now I've got a new one on the printer, I don't have to worry if I ruin it because I've got one on the printer, a new one. So these brass things here, this is where the problem is. So what I'm going to do is I'm going to grab this in my pliers and see if I can this end feels like, oh yeah, this end is really thin. It looks like the contacts have just burned through. So what I'm going to try and do is split this up if I can. The wire is just hanging on by a tiny thread there. At this point now, it's just hanging on. So maybe I can use these brass things again if I square them out a bit, I don't know. Maybe I can spread them out, I don't know. Or has the insulation gone on the other end, I don't know. Looks like the wires, this thermal wire stuff, it's all frayed at one end. Okay, you're back. Right. Well, this is where I've been having problems with this old hot end. Is the actual crimping. Or it might be the element itself. I'm not sure, but it's difficult to get these crimps off because they're really tight. I'm not sure how to do it. Actually, let me just try my. I thought what I'm going to do, I'm going to cut this wire off because it's no good. It's got to be redone anyway. I'm just going to cut these wires completely off. Right? Because they have to be redone anyway. And if I can salvage it, I'll salvage it. But if I can't, I can't. Now what I need to do is spread this crimping apart with my... I'm going to try using these pliers to somehow do that. If I can spread them apart and get it off, I don't know. I think I best off cutting part of this off actually. Right. Because it's just... If I can just get to the actual wires that come out of the element. I mean, I need to take this off completely, you see, because it might be the connection at this other end that's not working properly. Let's just test it with my meter actually. I mean, if it's not, then I could be able to. Right, I'll put my meter on this. Let's see if the element itself is bad. It should read about 4.2 ohms if it's good. Well, it's reading 5. Yeah, it's all over the place. It's 4.1 there. Oops, came off. It's jumping a bit. It might be just the brass I'm connected to. It might be. Not sure. Well, ideally, I really need to just take that brass stuff off completely because I suspect that the problem is down here, and it's a bit frayed right near the element down at the bottom there. There's some of the stuff's come away there. There's a bit of bare wire there as well. So if I can somehow get this brass thing off. I can squeeze it apart here a bit, so can I get it off? Oops, keep banging the camera, sorry. If I hold the wire, hold this, I'll see if I can get that stuff off. Oh! Damn it, the microphone's on the floor. At least it came off. Sorry about that. Sorry about that, Alan. Sorry. Right, that brass thing came off. That's really good. Right. So the brass crimping came off, which means I can probably clean this up actually if I stick it in some acetone or some ferric chloride or just use a file. So that one came off. Now let's take this insulation off here. Oh, yeah, the wire is very black and carbonised. The wire is extremely carbonised, which is obviously what the problem is, and the insulation just came straight off there. So, right, I'll see if I can get this other one off. I need to grip the wire with the pliers again. Sorry if it jumps, I'll try not to jerk the microphone and knock it on the floor again like last time. This one's on tight. The USB wire is going to get knocked if I'm not careful. It's still very tight as that one. But it's caused me problems for weeks of this thing. I'm glad I got a new one anyway. As they say, this has seen better days. I'm getting it. Can I get that off? I have to use my cutters to try to get this off here. I don't want to short anything out. I mean, I can put more insulation on there, I suppose. The brassy's got really chewed up. Or copper, whatever it is. I'm trying to get this loose. That stuff is just frayed off it. God, come on, keep up. I'll have to use my other pliers, I think. Ooh. This one's tight. try to get my knife in there. I'll rest on here. Don't take out the camera. Oh, right. I'll get my knife between that copper and spread it out a bit. I see some of the wires in here. I'm more worried about stabbing myself with this frigging knife. It's coming there, got it. Yay, got it. Right, we've got two wires coming out of the element. I'll take that insulation off now because it's shot, it's totally shot. I'm going to put some, what I'll do is, I'll strip the wires back on here. I'll use some of the insulation up here and redo them. Then I'll stick it in place with some resin or something. Now, the question is the element still good? If it is, I'll salvage it and repair it and keep it as a spare. Oh, that's loose. Right, so these wires are very, very carbonised, so that's probably the reason why it was giving bad connections. It's the metal, the copper of these wires is very black. It's very corroded. So let's get some emery paper on it and clean up these wires, because you can't really solder them because of all the heat. So they've got to be crimped. I think it might be salvageable. May well be. They're pretty thick wires, these. I want to clean them up, so I'm going to stick it on the meter and check it for continuity. And when I've cleaned up the top of this wire, I should have. If I get a good stable 4.1 ohm reading, then I'll know that the element's still good. I think it was just the crimping that was the problem. I might soak this whole thing in acetone actually, just clean it up a bit, because it's got a lot of black goo all over it. This is pretty thick wire, this. Right, if I put my meter on it, right, I'll just back the camera out of it. Should get a good 4.1 ohm resistance on here now. Well, I've still got carbonised wire, so it's reading 4 ohms. That's good. Looks like the element might be alright. I think the reason it's fluctuating is because the wire's not very clean still. But what I could easily do is, it runs on 12 volts, this heating element, so I could always run 12 volts into it and check it. But, yeah, what I'm thinking of doing actually is dipping these wires in ferric chloride, which is my etching solution. That should clean up all the gunk on the wires. And we should be able to salvage this. I don't know about the brass crimping pieces though. This is the only good one, this one here, because the other one's got mangled to hell because of me gripping it with pliers and it's just got totally chewed up. Actually, I don't suppose I need to use these. I could. I've got some crimping bits and bobs in a box, you know, that you use to wire crimp stuff. Any piece of brass or copper that's like this would work if I could crimp it on. So I should be able to salvage it and redo it all. You know, I think the knife is probably better for cleaning this wire. It definitely needs. It really wants a wire brush. I know what I could do. I could put my little electric drill on and use my wire brush on it, because that would clean up this wire a lot better than sandpaper would. It's very thick. Yeah, maybe putting ferric chloride on it is probably not a good idea. It would cause it to corrode. Yeah, I'm going to try some acetone actually. Let's soak these wires with acetone and clean them that way. Should work. Well, certainly seems to be. You know, I think this is steel wire. Let's try it on a magnet. No, it's not steel. I don't know what it is. It's not sticking to my magnet anyway. It might be carbon wire. This whole hot end wants cleaning up with acetone. It's really mucked up. I can't believe it. I bought this new brass hot tip, 8 months ago, and it looks like it's covered in black stuff. I don't know what that is. It must be the plastic that's carbonised. Yeah, I'm just going to squirt some more of this acetone on here to clean this up. really want soaking in an acetone container. I think I'll probably do that actually. That will clean it up really well. I don't think it'll affect the heating element though. I could take the heating element out actually. I think I will. That's an idea. I'll take the heating element out of the metal part, and I'll soak the whole metal part in acetone. That's what I'll do. So I need to loosen this screw. Take this element out. There we go. Oop! Where's it gone? Ah! There we go. That's the heating element. I actually used some thermal cement on that. I should clean up very well. So it looks like I'm going to be able to salvage this. Right. Right, that's the heating element out and cleaned up. And this whole metal block can go in an acetone soak. Because you never know, in the future at some point the new one might go wrong on me and I'll need a backup one. I'm looking for a container that I can soak it in. Maybe it's this one. I found one I can use. It's got a bit of yellow stuff in there. I'll just take that out. Right, so I'm just going to soak this whole block in this container. Actually, I need to fill the container up. Right, I'll just get some more. I hate these child-proof caps, they're a bloody pain. Especially when there's no kids around here. Right, this should clean it all up. Right, it's completely submerged now and it's going to soak. That will get rid of all that gunk off the thing. And then I can start thinking about re-crimping all this. But having this off the thing is actually makes it a bit easier now to clean up the wires. Actually, I don't even need to use my drill. If I just get the wire brush, I've got a steel wire. I've got a steel wire brush in here somewhere. There we go. Don't need to put drill on. I might break the wire off if I start putting it under power, you see. I was thinking about the vibration, it might break the wires. I'll just use this rotary wire, mini wire brush, and I'll just stroke these wires with it. And that should sort them out. I haven't got a, this is a very fine wire brush as well, which is what I want. Those great big handheld wire brushes would be no good because they're too thick, the bristles are too thick, but this is fine, so it's just right. Well, I have no idea, Alan. It's money as well at the moment. I mean, I have to go. I'm going to see the engineering firm and look at getting an aluminium base. I need to know how much they're going to want me to pay for that, and then I'm going to be taking it a few steps and getting the threaded rods and the nuts and everything. And I don't know. Then there's the motor as well. I mean, I was thinking about using a stepper motor and using a stepper motor driver to run the motor, but obviously I need to get them in physical build done first, because I could always run the chuck off a drill or something, or an electric screwdriver even, I don't know. But I mean, I just don't know. I mean, the money I had from my mum, that's gone anyway. So I'm back to budgeting everything now. So we're just going to take it a step at a time, really. These bristles are sharp. I think I've got these wires cleaned up now. They look a lot better, that's for sure. Well, a stepper motor it's got a lot of torque. Well, it won't run extremely fast. I don't want it to run fast because speed creates heat and friction. And if I'm working with plastics, you have to work on a slow speed anyway. Because if you know yourself, if you use electric drill to drill a hole in plastic, the friction melts the plastic, unless you turn it really slowly, in which case it doesn't. Because friction just creates a lot of heat. So I think if I get a stepper that's got a lot of torque, it would do the job. Otherwise, I'd have to use some kind of a gearbox and a motor of some kind. nice and cleaned up. The wires are a lot shinier, and the white brushes certainly help that. Let's have a look at this, see how this is soaking in the acetone. It's coming clean, it's cleaning up. Yeah, I'll test and find out. I really could do with a spare stepper motor though, to be honest with you. I was thinking about buying a stepper motor that was exactly the same as the one on the 3D printer. That way, if anything ever went wrong with the 3D printer, I would have a spare, like if the stepper motor went wrong, I'd have a spare one. And there is an imbalance on the Z. Anyway, there's two Z stepper motors on this printer, and one always seems to run faster than the other one. I'm not sure why. It might be because of the length of the cables between the board and the stepper motor, or it might be because one motor is weaker than the other. So it would be an idea to get another stepper motor as a Z replacement, and then use the old one to run my mini lathe. And then that way I've got compatibility, you see. I could always use it for something else if it turned out it was no good for the lathe. But they have got a lot of torque. And you can get stepper motor drivers off eBay as well. I need to see if I can get this out of here with a magnet. I hope so. Oh yeah, it's magnetic. Right. I need to lift it to the top. Oh, I've dropped it. I'm going to leave the lid on until I get it up. Right. See if I can get this out of here. Oops. I don't want to spill my acetone. It says it's steel, so it should be magnetic. Right, it's coming out. Right. I need to agitate this and clean it with a tissue now. I don't know if I've got it soaked long enough though. Might want to go back in. This black tarnish is going to be hard to get off. I think I'll have to use my wire brush to clean some of this off. Yeah, that's going to work. Yeah, if I clean this up, it'll look like new. Yeah, the wire brush is working. The new one I put on shouldn't get like this because I covered it in the thermal tape, which will keep it protected really, but the thermal tape I suppose will eventually go tarnished anyway. It's a lot better now. probably should put my drill on actually and put this under power now to do this really. Alright Alan, you take care. Yeah, this is cleaning up quite well anyway. You take care. I'll probably kill the stream in a bit. There wasn't much to talk about really. But apart from the slight offset problem I'm having with the printer, but it's not an offset really, it's some kind of a calibration problem. I've got I'm on the support forums and Repetier to try and find us an answer to that. So you take care anyway. Yeah, so it looks like the element's okay. It's just the wiring, so we'll sort that out. Ouch! God, that's sharp. I have to put this on my drill, I think. Right, that's cleaned up as good as I can get it. Well, as good as I can get it without putting my drill on, and I'm not going to do that. I just really just want to get this element sorted out. And so, yeah. I need to clean this hole out as well. I never thought I'd be using second-hand used cotton buds, which I'm at the moment, so I need to get some more. But, oh well. Right, that's a bit better. So it's just sorting the wires out now. And crimping. Well, that other one's chewed up to buggery, so I don't think I'll be able to use that. I'll find another one. I've got this one's not bad, but yeah, I've got a box of crimping things. I can probably find something. Oops, where's that gone? This one's not so bad though. I don't think I can get the wire in there. That's the problem. Well, one trick is to jam something down in it and then bash it with an hammer to spread it out. I could try that, I suppose. I'll get the screwdriver in. If I can salvage one of them, it will be something. Well, it only came on live temporarily just to let Alan know what's going on. Right. Oh, there's some wire sticking out really. These elements, I'm just wondering if you can solder to them. I don't think the temperature of this element at 260 degrees Celsius is hot enough to melt lead solder. So I don't know if you can solder to them. If you can, I would rather do that really, but I don't know. Anyway, I'm out.